Hey guys, it's Cugsley, and welcome back to another video. So, I'm making this because last night I did a live stream where I was working on some logic, and I came across something cool that I've been trying to do for a while, and I finally figured out how to get it done. So, to give you context, in the game I'm currently making, I use something called an input router, which is this right here. What this is, basically, is it takes an integer. So let's make this simple. 1, 2, 3, 4, 5, 6, 8. All right. So it takes a number, right, up to 9,999,999, all the way down to 0, right? Any number within that range. So it takes that number, it splits that number into individual digits, right? You can see right here. It then rounds down the digits so that way there's not any decimals, so it takes them down to whole numbers, and then is able to check for any particular number. Like, is there a 1 in here? If there is, this will light up. I put these here for visual markers. These keyframes don't do anything. These are just like, they just light up so you can see as it, calculates, right? So it's basically able to check and say, hey, is there a number that I'm looking for in this larger number? Split it, round it, check it, right? Now, noticeably, there is a lot going on here, right? I mean, you take the number, you divide it, you get the million spot. You do a remainder of 1 million to get 100,000. You divide it by 100,000 to get 2.3, right? You round down 2.3 and you end up with 2. And so now you have the 100,000 spot. Same thing for 3, 4, 5, 6, and then 8, right? Or same thing for each digit place. So a lot of math going on there, but more importantly, a lot of gadgets and a lot of wires. All these like white little spaghetti lines here, and these as well. A lot of wires doing a lot of things. I have since found a way to cheapen this. Granted, there are positives and negatives to both of these systems as they currently are. Here is the new system. So immediately, first thing you notice is this is a lot more efficient, right? I mean, there's a lot less going on here. I'll explain how the math of this works really quickly. If you are a programmer and you are aware of like recursive kind of loops, right? Or like I think it's like nested loops. Is it? I'm trying to remember. Basically, it's like like recursion, right? If you're familiar with recursion, that's what this is doing. Basically, it's just going in on itself constantly and changing the math behind how it functions. You can see it right there, right? Whereas this here is not doing that. This is basically a bunch of if statements and the calculations, right? It's basically just saying, hey, isolate the first digit, check it. Isolate the second digit, check it. Isolate the third digit, check it. Fourth, check it. Fifth, check it. Sixth, check it. Seventh, check it, right? The thing is, this is instantaneous. I mean, if I were to change this value immediately, everything updates and it shows all of the digits that are active, right? So you can see 1, 7, 8, 9, right, and 0. These are all the digits available in here. 1, 7, 8, 9, and I'm not checking for 0, so there's no check for 0. But you would be able to find a 0 here too, right? So immediately you see that this is really quick, super fast, no lag, no latency. This one is extremely space saving, but it has a refresh rate, as I'm sure you're noticing here, where it takes time to go through every single digit and check it manually. The thing is, really efficient, and in a regular computer, this would be the better way to go about it, because computers refresh so quickly that it does thousands of calculations in a second. So this would basically be instantaneous for the viewer, right? Whereas this would be, I suppose, just about as fast, but it's like, ugh, there's a lot going on there, right? I mean, that's a lot of code that you're writing that you don't really need to. But basically, in Dreams, I found a way to do this, and this still has its use. If you have a program that doesn't need to have an instantaneous kind of parsing of data to send off, like if it doesn't need to be instantaneous, then this is a lot faster. Because basically, I can say, hey, I want to check a 7-digit long number. What it does, and I'm going to have to get rid of this wire here to simplify it, is it takes this number, it runs it through a remainder, right, of say 10, and then it gets 7, right, and it then divides that by 10 again, right, to get 0.7, multiplies it by 10, then rounds it back up to 7 and sends it off. And the reason it does that is because if you have larger numbers, think 100, right? Now you're doing 67. Oh, fuck me. Hold on a moment. You're doing 68, right? It takes 68, divides that by 100 to get it would be 0.68, right? And then multiplies that by 10 to get 6.8, and then round it down to 6. So that's why I like divide it and then multiply it, because this does change. And the way it works here basically is, I'll go step by step because I just kind of showed you the general math of it. It takes a particular remainder, right? And it will constantly update this. It'll go really quickly, like it'll look like that, right? But it takes a remainder. It isolates the number that it's looking for, right, into a single digit. And then what it does here is it actually takes the factor that it was dividing. It takes the factor that it's dividing by, right, and it runs it through here and multiplies that by 10 to get the next like digit step up, runs that through here. Well, that was a weird noise. Runs it through here, and what this would do is basically this would have a ridiculously large remainder, so this is constantly going up, right? This basically means that it's just going to pass through whatever value goes into it, takes it into here, and this right here is a calculator that takes the largest number compared between two, and it sends it back into this remainder to then do a remainder of this here. So what you end up seeing is something like this. So you see it's constantly updating because it passes through, sends off, passes through, sends off, passes through, sends off, and this is constantly increasing. Once it gets too big, though, the remainder of this and this ends up equaling 0. So then it sends through 10 because now 10 is the largest, and it resets this remainder kind of calculation back to 10, and therefore this starts back off at 10 and starts multiplying itself by every 10th digit again. So it ends up doing this kind of loop. Cool thing is it works even when the game is paused, because the calculations, it's kind of the same thing as making a paradox, where if you were to plug a NOT gate into itself, a NOT gate inverses its input for its output. So if its input is on, its output is off. So right now there's no input, so its output is on. If I plug it into itself, well, now its input is on, so its output is off. But if its input is on and its output is off, then its input is off, so its output is on. So it's constantly going back and forth on itself. So this works even when paused because it creates kind of a contradiction. Same thing with this. Because of the fact that it's constantly iterating on top of itself, it doesn't actually, like, the scene doesn't need to be unpaused for it to function. Because of the fact that the numbers are constantly in conflict and they can't settle. So this, super efficient. I mean, there's not really much going on here. I mean, if you're checking for 9 different digits, then you see this. But for example, there are 25 objects here, right, in this program. So 25 pieces of logic that are doing calculations, including the value setter. Over here, there are 44 objects. I say 44 because technically this node just kind of distributes this value. This node isn't necessary. So we'll say 44. So it's 44 objects versus, again, 25. So it's almost half as, this is almost half the size of the old array, or like, called it like array value finder because I'm treating this like an array by then splitting it and then recombining it, but of the old integer, like checker. So I've created a more streamlined system. The only issue is, again, it has a refresh rate, which might not be perfect for all use cases. Like for me in particular, because I am using these kinds of like programming bits to check for inputs, because I have my own custom input system for this character model. Because I'm checking for inputs, I can't really have it taking super long to refresh every single check that it does, because if it takes too long to refresh and you press a button when it's not checking for that button, you'll end up pressing a button and not doing anything when it should say jump. So I'm still using the old system for this, and I use a different. I'm not checking for every single value. I'm just checking for 2 and 5. So I simplified this. That's why I don't see like 9 different calculators and a bunch of colored keyframes. It's just this little bit here. But this right here is what I'm talking about. Because of the fact that I have to do live checking where it goes considerably faster than the refresh rate that I just established, this means that the player will press a button and something will actually happen. It's instantaneous. So the system that I just made, again being the procedural kind of digit checker, useful, not useful for what I'm trying to do, but it's useful for something. Probably slower programs where you just have to do a quick check, because I mean it takes I think it's 0.4 or 0.04 seconds for it to. Here's what you do. You just how long does it actually take? I think it takes like 0.4 seconds. Yeah, okay, it takes 0.0. Hold on a moment. Set that to 1. Okay, so it takes 0.2 seconds for it to check a 7-digit number all the way through, right? So, I mean, if you're doing like a slower program where you don't have to mince milliseconds as badly to run your operations, then this is pretty good. I mean, a fifth of a second isn't bad. It's definitely not preferable for a lot of faster kind of processes, but it's okay. If you're going for efficient, surely one way to do it. But yeah, I just thought I'd show this off because I'm pretty proud of it. It's probably a pretty simple thing to do in actual like programming languages, but it was a little bit of a challenge here, I guess, just because of the fact that I couldn't really tell the computer what to do. I just had to put a bunch of calculators and walk my way through it. But I got it done. One thing I might try to do in the future, if I can do so without taking up a bunch of space to implement it, is make it, because this remainder here is what determines the range that it's able to check, right? The smaller this number is, the faster it loops over itself, because it starts cutting off the millions and the 100,000s and the 10,000s and the 1,000s. So it'll, because it checks this direction. So it starts off in the ones place and then it scales itself up and checks every digit, reaches here, and then resets. So the lower this number is, the faster the remainder is hit and it zeroes itself back out. Which means if I could find a way, I would want to see if there's some sort of method I can use to basically check the range of the input and accommodate this number here to that range. So that way, if you're only dealing with 568, you're not going to check for the thousands, 10,000, 100,000, millions, because then it's just wasted space, right? It's going to return nothing no matter what you do because you only have a 3-digit number. So I'm going to see if I can try and find an efficient way to implement that. I know I can do it. It's just it wouldn't be very efficient. So I'm trying to figure that out. I want to see if I can do it with only like maybe 6 objects, but we'll see. Anyways, that's it. I just wanted to show this off. I might do a stream later where I work on some more level design stuff, but I just thought I'd upload this because I was working on it last night and I was delirious and tired, but I simplified it this morning. So, good stuff. All right, bye!